Hey everybody, thanks for joining me on today's webinar. My name's Adam Walmsley. I'm a technical specialist at Autodesk, looking after everything relating to civil infrastructure. And today's webinar is going to focus on how we can take your drone imagery all the way from capturing it out in the field through to bringing it into an environment using Recap, InfraWorks, and then taking that out to something like Civil 3D or even Revit. I suppose at the end of the webinar, I'm going to show you how you can quickly create something like this that you can see on the screen based off the accurate point cloud imagery that we first started with. So let's get started, shall we? So what I'm going to do is I'm going to open up Autodesk Recap Pro, and I'll also show you just quickly, we have a series of photos here that we have taken of this particular site. It's important to know that if we just check out the properties of one of these photos, go to details, you'll see that we have flown with a DJI Phantom 4 Pro. It's about 20 megapixel camera, I believe, which is quite good. But what's really important about today's webinar is the GPS information that gets captured in each of these photos. Now that's what Recap Photo is going to use to process the imagery and stitch together the photos which give us our end result. So back over here in Recap Pro, we're going to go to New Project. We're going to click Photo to 3D. This will launch Recap Pro, excuse me, inside of Recap. And now we can start to use this interface to create our project. So what we're going to do is we're going to start with an aerial. In this view, we're going to click anywhere. We could also click here to add photos. Let's just do this. Quite simply, select all the photos, scroll down to the bottom. Okay, now in this flight that we did, we had a series of photos in another folder, so I'm going to add them in as well. Now, we have a total of 528 photos, which you can see up in the top right hand corner. It's also important to know that we're going to consume cloud credits to do this type of processing. But before we can do that, we need to use a series of ground control points, assign them to our images so we get a much more accurate representation of our point cloud and of our mesh when all this gets stitched together. So how do we do that? Over here on the left, we have our ground control points button. We're going to click that. Now this will bring up a window here and you can add in some control points. So going back just a step, we've got a series of ground control points which we have acquired. I'm just going to copy that information, paste it in there quite simply. So now what we have is our eastings, northings and RLs, 23 control points, and the photos that have picked up that control point number 1. So if we go to the map view here, you'll see that this is our site. You can see all of the photos here that we have captured in our drone flyover, and each of these pins here shows a control point. So quite simply, all we need to start to do is to assign a control point to a series of photographs. So let's just start with number 1. We can click to tag photos here. Now I know because we shot this that control point number 1 is this manhole in this vicinity here. Now if you look at this area, we can see that there's some feature here and there's a feature here. We can sort of use that as a base to work out the other, look at the other photos. So clicking simply there drops a marker. Now in this window, you can also refine the selection and placement of your ground control point. So we're going to try and get that in the center, and we can zoom in and zoom out there. Once we hit done, it's going to tell us that we need to place 3 more ground control points on 3 more images. So let's go over to the next photo here. I can see that there is our manhole. So we'll go in, click that, refine that. Let's check this one out. There's our manhole here. Done. And lastly, we will not use that one. Let's try this one. Yep, there we go. Okay. Once that's done, you'll see we have a green tick here. And we can go through this list and then start to fill out or select the ground control points on the images for each one of these points. Now, best practice advice is to do as many of these as possible. It will help create a more accurate model once it gets processed. Now, just to show you guys, not all of these points are going to be processed because some of our ground control points are actually out of the zone of where we don't have any photographs in this case. So you could just ignore those, so that's not a problem. I'm not going to go through and do all of these today just because of time, but I've just showed you how you can do the first one there. So once that's done, then we have the create button down the bottom here. Selecting that, we will give the project a name, so drone to design. We have options here of what output we want to receive from the cloud. So we want the textured mesh, the RCM. We also are interested in the point cloud for today, and we definitely want an ortho photo, a GeoTIFF. We need to select our target coordinate system, which is CO83. No, that's not it. MO83. Apologize. Okay. And then you can see here that it's going to consume 30 cloud credits, and we have 99 available. If you don't have any cloud credits, you can purchase them. The purpose of this is that we are going to upload these photos to the cloud, and the cloud is going to do a whole series of processing, so it saves our computer that grunt work. Once we hit start, and now you can see at the bottom here that our design is starting to upload, and that's going to take some time depending on your internet connection. So I did this process yesterday, so I'm not going to go through this whole thing today just because of the time that it does take. I think it will take several hours for this output to return to us. So to show you the finished product, I suppose, this is the information that I did receive. Now, you get a series of zip files with information in them, and you get the RCM. I've extracted the zip files, and you can see here we have our TIFF files, which is the overlay imagery. We have our RCM, and we also have our RCP, which is a point cloud file. So if I go ahead and open the RCM, you will see that this is the textured mesh that has been created from our point cloud scan. So if we zoom in and start to pan around a bit, you can start to see the level of detail that we've gotten from this scan. An area that is worth showing is, where is it? It's in here. You can see that there is almost a vertical cut in this region, and the mesh has shown this quite nicely. So this is a really detailed output from the 500 photos that we processed from our drone. Close that. If I open up the RCP file, this is the same thing, but the point cloud data. You can see the points there as we navigate around. So going into the same zone over here, you'll see that, where is that rock cut? There it is. You can see that cut there, and all the points associated with that. So you can see the output we received back from Recap Photo is actually quite detailed. Okay. Now once that's done, we're going to jump over to InfraWorks, and we're going to start to bring this stuff into the model. we're using InfraWorks in the normal way, creating a model using Model Builder. I've done this in advance, so just in a matter of time. But you can see this is the area here, which we have flown our drone over. And inside of Navisworks, it's given us all the roads, and it's given us a JPEG overlay, and you can sort of see the terrain that is in there now. So what we're going to do is we're going to bring in the aerial imagery from the TIFF that we have reported. And now if you look at this building, you can see how sort of rough that is. Same with this, it's not the greatest image quality there. But by bringing in the GeoTIFF, this can really sharpen things up. So what I've done is I've created a proposal called image overlay. And previously to this, I've brought in the TIFF file here that we have got out of recap photo. And now if we zoom in, you can see the different level of detail that you get when you overlay that TIFF file in our environment here in InfraWorks. Much more detailed than what you get out of the box. If we pan around a little bit, you'll see that the terrain is in there as well, but I think we can sharpen that up by bringing in the point cloud that we have as well. So what we can do is bring in point cloud. You can bring in that RCP file, and you set up the coordinate systems, and it comes in quite nicely. Now if we just go to Model Explorer, I've already done that. So what we can see, if I just turn that point cloud on, let it load for a second. Pan around a little bit, and you can start to see now the point cloud that we have in there alongside the terrain that InfraWorks has generated out of the box. Now, because of the accuracy of our point cloud versus the accuracy of the out-of-the-box terrain, we can't see any points in here at this point in time, but the points are actually underneath that terrain. So what we're going to do to fix this up is the feature in InfraWorks called Point Cloud Terrain. This will open up a window, lets you select the point cloud that you have in this model, and you can apply some processing rules to it, and then you can hit the Start Processing button. Again, due to time, I've already done this. I've got it in another proposal, and I'm going to show you what the output looks like. So if I turn off the point cloud scan, you will now see that we have the high resolution imagery in here from our TIFF, but we also have a new terrain that really closely matches up nicely with what the output from our photos are. You can see that if I turn on the point cloud here, you can see the trees pop up in the background, but in this zone, you can barely see any points. It's come in quite nicely with the existing terrain there. So you can see how with a bit of processing, you can take your photos from a drone, as long as they're geolocated, process them with recap photo. Out of that, you end up with the RCM file. You get the point cloud, and you get the high resolution GeoTIFF. Combining all of that data together into InfraWorks results in an environment that is ready to go to start your concept designs, and then sending that information out to something like Civil 3D or Revit for further analysis. So let's say now we are going to work in this area where our current bridge is. I'm going to, just for the sake of today's exercise, put another bridge in here and show you how we can sort of get it up looking like this bridge. And then we can also show you how we can then take this information, this terrain data, out to something like Civil 3D for further analysis. So over here, we are going to create a component road. We are going to keep that on the bridge 4 lane for now. Let's change that. Let's make that. No, we'll leave it. That's okay. Now let's just sketch from here to here. Double click. We've got our really basic component road here. What we want to do is just look at it in a profile view. I'm going to tidy this up a little bit. I'm just going to remove this point of vertical intersection, and I'm also going to remove this point too. It means we've got a straight grade from this part of the road to this part of the road. Now we're going to place our parametric bridge. So let's say we'll start from back here somewhere, and let's end the bridge about there. We now have the basics of our bridge. Selecting this road again, what we might do is add another PVI here, just to get above the ground here a little bit. Drag that up a little bit higher, and let the model update. Okay, we can close this now, and yeah, that's it. Okay, so now spinning around, you can start to see that pretty quickly we've got a nice looking bridge in this model, but we want to refine it a little bit. So looking at the structure here, I'm going to change the assembly. I want to work with Open Super Tees. Double click. And the model is updating as we speak. You can see here by clicking one girder, we're using T4 type girders, which is familiar to people in Australia. Okay, we can change the piers. Let's go blade wall. We'll go sloped. Once we're happy with that, we can also apply it to all piers. That one's updated as well. Footings, we can amend that slightly. We want one row. And we only want 4 piles. Change the spacing here to 5. Once we're happy with that, we can apply that to all the pier foundations. That updates too. Looking at the pier locations themselves, we can say, okay, we want this to be more centered in between the two roadways. Simply drag that across here. And you also have the ability to add your skew values. Rotate that around a touch. So now looking at that skew, we can see that it's 9.74. We're going to apply that rotation to that pier as well as our abutments. $9.74. I'm not loving that abutment, so let's change it to an enhanced abutment. So we can get some piles underneath it. Now you can see the wing wall skew is all a bit off. So if we change this to, where are we? Wing wall skew 9.74. And 9.74. The skews on those abutments now are more in line with the skew of the rest of the bridge. Once we're happy with that, we can apply those changes to all the abutments. So from a concept design perspective, this might be all you would need to start talking to your clients and showing them the proposed work. You can always get a little bit fancy and start adding things like cars or people to sort of start to animate your design a little bit more, just to show you that it's part of city furniture. So let's just add a Porsche Cayenne here, double click. You can rotate that around. There we go. Move it to where we want. And that's in. So you can see how InfraWorks is a really cool tool to quickly come up with sketches for some of your bridge designs. Excuse me. And you can see that we're using the levels of this bridge based off the really good value terrain data, point cloud information that we've obtained from our own drone scans. Now, I think it's becoming more popular these days that a lot of companies are starting to invest in drone technology and drone pilots, and this just goes to show you the type of output that you can get pretty quickly by leveraging some of those resources in-house. So finally, we're going to take our site and we're going to export it out and bring it into Civil 3D and show you what that looks like. Now, we're going to use the export IMX file. Here we have the ability to choose the extent, so we can use a polygon or a bounding box, and we can, if we use a bounding box, we can start here and we can double click and then we get our extent of export, or we could just use the entire model and you have an option to see where you want to save that. Again, just in a matter of time, I've pre-prepared this. So let's just jump out of InfraWorks, open up Civil 3D. We'll open up this file here. It's also important to know you do need to close InfraWorks down and get out of the model before you open up the model. Otherwise, you do get some errors. I learned that the hard way. InfraWorks model, I've gone in here and I've set up my coordinate system, which is always critical for these types of processes. So I won't show you how that's done. That's pretty straightforward. We're going to select the SQLite. This is the file that I had been working with previously. Now you'll see that the coordinate systems match up perfectly, so that's good. You have the ability to select the area of interest, which is what we're going to do. Activating this opens up the geolocation feature, and you'll see the aerial image come in here. Let's just focus on this small area for now. We can refine our selection set. We don't want any roads in this case, but we do want the existing ground surface. Hit OK, open model. We can turn off our geolocation map. And what you end up with is a tin in here. Let's change this style to a bit more detailed. And you can see the contours that have come in. This area is where that cut was in our mesh and the vertical cut, and you can see how closely together these contours are. So you're getting some really accurate information in here. So let's say you want to do some basic road design as an example. We'll just create a really quick alignment in here. We'll just put that on there, and let's just draw a road from here to here out to there. Ooh, scale's gone a bit funny, but that's okay. So there's our alignment. Okay, hit save on that model. Open up InfoWorks. Open up our model. Now what we're going to do, just to show you guys how this can look, is we're going to import that Civil 3D file in to here and see what comes in. So go back to data sources. We want to bring in a Civil 3D DWG. Navigate to the file location, which is drone surface. Now what we're interested in is just the roads that we've created. So select OK on that. Configure this. Now you see alignment 1, which is the alignment that we'd created. Coordinate systems are all in line. We want to drape that on the elevation, on the surface, sorry. And we can play with some of these settings. So let's just change the style to, no, we'll leave that as it is. No, let's change that style. Let's make it a 2 lanes. Hit close and refresh. You see that real basic alignment that we brought in here has draped itself on the surface, the terrain that we've created, and that actually matches what we've got over here in Civil 3D. So you can start to see how using the recap photo process to bring your photos in, send them to the cloud for some publishing, stitch them together with ground control points. You download the export, you get the recap mesh, you get a point cloud, you get the TIFF, and then as I've shown you, overlaying all that information in InfoWorks is really a nice way to be able to start your design process from concept all the way through to detailed design, using exporting out the surface to Civil 3D and bringing it in and then adding some alignments and whatever other work you need to do in that space. So with that, I'm going to wrap it up there. If you guys have any questions on what I've spoken about today, please feel free to reach out to me. You can get me on LinkedIn, search my name, or adam.walmsley@autodesk.com. And I look forward to speaking to you soon. Thanks. Bye.